Splish splash, I was taking a bath. Long about a Saturday night. Yeah. Rubbed up, just relaxing in the tub, thinking everything was alright. Well, I stepped out the tub, I put my feet on the floor, I wrapped the towel around.
Thank you for joining me today. I'm Amarette Gent with Lincoln Motors, and joining me today is Carl Verlinden with Cornell Pump Company. Today we're going to discuss the Immersible motor. Carl, thank you for joining me today.
Well, you're welcome. Thank you for being here. Let's have a look at this motor.
Well, why don't you start off with telling me what exactly is an immersible motor?
An immersible motor is basically a TEFC motor that is designed to run in air, but for limited periods of time can run underwater.
But isn't that a submersible motor?
No, a submersible motor is a motor that's designed to run underwater all the time, as opposed to, like I said, the TEFC motor that will only do it for a short period of time.
Well, where would you use an immersible motor?
The ideal application for an immersible motor would be in a dry pit application that's located in a flood zone. No, floods may happen once in a lifetime, but when they do happen, you really want your pumps to work. So an immersible motor during a time when there's no flood will be very happy running in air, but when a flood does happen and the pit floods, it will keep operating while it's underwater.
Can you tell me how it works?
Yes, we have a picture of it here. Basically, a standard TEFC motor. There's three places where water can get in. The first one is in all the joints, but those are all O-ringed, so we've got that covered. The second is in the conduit box, but those are all machine surfaces that are gasketed, so those are covered. And then the third place is at the bottom where the shaft comes out of the casting. Now there we have a triple redundant seal. What that basically means is there's three ways we keep water out that all back each other up. The first one, and probably the most simple, is that there's an inverted cup. And if you hold a plastic cup upside down and put it in water, obviously it traps air and water doesn't go up. It's backed up by an expeller, which is basically a small impeller that creates a vacuum and thereby keeps water out. And backing that up is a dual lip seal with pressurized grease to keep water out. So there's really no way water can get into this motor.
Well, what about that little blower motor on top?
That drives the little motor, or the little blower, and it's designed to run underwater. You can flood that and it will have no adverse effects on it at all.
So what are the advantages of running that immersible motor versus the submersible motor?
Really, you can divide the advantages into three different areas. The first one being maintenance. In order to run a submersible motor, as I mentioned, you have to have the jacket, and the motor will use the sewage for cooling. Sewage not being a clear liquid, chances are that it might plug, barnacles might form inside the jacket, which will create hot spots in the motor and obviously not extend the motor life a whole lot. So a submersible motor is a lot more maintenance intensive than an immersible motor. Another big advantage of the immersible motor, since it's standard TEFC, anybody can work on it. You don't have to have a special shop that only works on the submersibles. And if you do need work on the motor, you can grab any motor off the shelf, put it on while your immersible motor is being repaired, so you're not shut down. The second area of advantages would be in the operational area. TEFC motors are significantly more efficient than submersible motors. And obviously, if they draw less energy, they cost less to run. In the operational end too, immersible motors can be P-based motors, with the higher horsepower, so that the hydraulic loads are borne by the bearings in the base rather than the bearings in the motor that you have for the submersible, which are all close coupled. And then last, they're less costly to buy. So if you really look at the advantages And let's face it, in the municipal market, the advantages pretty much always translate into dollars. They cost less to buy. They cost less to run because they're more efficient. And they cost a lot less to maintain.
Well, that sounds great. Do you have one that we can go take a look at?
As a matter of fact, yes, we do. We have one in the test lab. So let's head out there, and on the way, let's pick up Mark, who has had quite a hand in developing this motor. And I'm sure he'd like to show you the test.
Great.
This is Emmerette Gent from Lincoln Motors.
Hi, Emmerette. How are you?
We've chatted about the immersible motor for a little bit, and she would like to see one do its thing. Told her you were the guy that developed it, so.
Well, we can have a demo in probably 10 minutes or so.
Right.
Right now, this is the actual motor. It's an enclosed type motor, and it utilizes a blower up on the top for the cooling. The blower is of a wash-through design. It does not mind being underwater. It can flood with water. The water will receive back, and there will be no problem, no service or anything associated with, maintaining that particular blower. So when I mean by enclosed design, the shaft does not protrude through the top of the motor, and so the motor on the top is dead-ended. All the actual connections and joints are O-ringed, so there will be no water seepage past these connections. The conduit box is on the other side, and it is gasketed. The only other area is the shaft, and the leakage most likely probably will happen along the side of the shaft. Now, and we look at it as they lift the motor up. This is a P-base bracket, just a standard type. We've designed the inside of the bracket as an inverted cup, basically to trap air if the water is actually, filling up a confined area. So you got an inverted cup. We provide double shaft seals on the shaft, and we provide a pressurized grease system to lubricate them and to keep the water outside the enclosure between the seals. And the last thing is we have a spare part we call the expeller. The expeller, it's like an impeller. It got multi-vanes. We fix it to the shaft, rotates with the motor. As it rotates, it actually will create centrifugal forces, try to expel the water out, and we will actually produce a vacuum right at the center of this particular bore. The vacuum going to be vary from -4 to about -11 psi. With this particular vacuum, you actually will not be, there is no way for the water to actually protrude along the shaft into the motor, because we'll be trying to draw grease out of the motor to the outside. So you have a triple protection mechanism. You got an inverted cup, you've got a double shaft seals, you've got a pressurized pressurized grease system, and you also got an expeller. There is no way for the water to get into that particular motor. That's basically it. Well, we're going to take it out to the. We have a pit here. It's roughly about 20 feet deep, and we're going to try to dip it under the water, running, and we'll probably take some shots from the top. And we've asked Carl to actually put his gear and get into the water and take some shots under the water. You know, that's about it. That's the program for today.
Great.
Thanks.
mentioned earlier, the motor end bell has an inverted cup design. The purpose of this particular design is to trap air in the cup cavity to isolate the water from the motor opening where the shaft comes through and where the shaft seals are located. As you can plainly see, there is a massive bubble that has formed inside the motor end bell. You can actually see the reflection of the expeller on that particular bubble surface.